Okay. All right, so this should be a review for you guys. 3-2 is the product and the quotient rules. Okay, so the product rule, that's the first one here, okay, is basically if you have two quantities that are being multiplied together, you can use the product rule instead of having to FOIL and then derive. Okay, so this right here is exactly the way I would say this just to help you remember. Okay, the F is standing for the first. So if you have your first quantity, that's the first one. And then the second quantity, I would say this as first D second plus second D first. Okay, and hopefully you remember that from last year. That kind of helps you put that into your brain forever, I guess. Okay, so when I say D, what do I mean by D? Derivative. So it's the first times the derivative of the second plus the second times the derivative of the first. Okay, quotient rule, this is the one for some reason everybody remembers. If you have a fraction, you have a high on the top and you have a ho on the bottom. So how does it go? Who remembers? Ho d high minus high d ho over ho ho. Okay, so the ho is squared on the bottom. Okay. All right, so let's do an example. Let's start with number one. So which rule am I going to use for number one? Product rule, right? Okay. Okay, so the first quantity, and that's the second one. So by definition, the product rule says the first. So I write the first quantity, 3x squared minus 2, times the derivative of the second. What's the derivative of the second? 2. Plus the second quantity times the derivative of the first. So what's the derivative of the first? 6x. Okay, and then I just simplify that. Okay, so I'm going to distribute the 2 through on the first quantity, so I get, let's see, 6x squared minus 4, and then distribute the 6x through the second quantity and get 12x squared plus 18x. Okay, for our like terms, how many x squareds do we have? 18x squareds. We have 18x's and minus 4. Okay, so that is it. That's pretty easy. Good. Check. Awesome. Okay, now just so you guys realize, is there another way I could have gone about doing that? Question number one. Right, I could have initially FOILed it and then just derived it using basic method. Okay, so just realize when you have something like that, there are two possibilities. You don't have to use the product rule. Sometimes the product rule is faster and sometimes it's not. Okay, so use it when it's faster. The quotient rule, however, there's no going around the quotient rule. If we have a fraction with a quantity on the top and a quantity on the bottom, there's no other way to do it. You have to do the quotient rule. Okay, so how does the quotient rule go? Okay, so I start with the ho, so I start with the bottom. 2 minus 3x times the high, the derivative of the top. What's the derivative of the top? 4x minus 4 minus the ho, or the high, the high, times the derivative of the ho. What's the derivative of the denominator? -3. And that's all going to be over the ho squared. Okay, now here is a tip for you guys. Anytime you're dealing with fractions and you have quantities, never, ever, ever FOIL the denominator. Okay, so see how we have a quantity in the bottom that's FOILed, or squared, excuse me? Do not FOIL that. Okay, only mess with the top stuff. Okay, we want to simplify it. If we can put it into factored form, we want to try to do that. We'll see if this one can be. Okay, so on the top, I have to start by foiling those two quantities. So what's 2 times 4x? 8x. And then I have 2 times -4, so -8. Then I have -3x times 4x minus 12x squared, and then plus 12x. Hey. Don't worry, I have minus, and then I have times the -3. I'm going to just distribute a +3 through that. Does everybody follow that? Because I have minus and negative, so I'm going to distribute a +3 through this. So it's going to be 2x squared times 3, so 6x squared, minus 12x plus 9. Am I? Oh, on the 12x squared. Good catch, thank you. Okay, so on the top, we're going to combine like terms. So how many x squareds do I have? So -6x squareds. How many constants? Or not constants, excuse me, how many x's? So I have, those ones cancel, so 8 x's. And then my constant -8 plus 9, so 1. Okay, so most of the time I'm going to be done at this point. I do want to see if I can possibly factor the top because it could cancel with the bottom. Does that look factorable on top? No way. Okay, so we're going to call that quits at that point. Okay, moving to question number 3. Now, if you looked at question number 3, could you derive question number 3 using the basic method? Yes, you could pull the x upstairs and do basic method on it. Okay, but you can also use quotient rule on this. Okay, which is what we're going to do. We're going to do quotient rule on question number 3. Okay, so if we do the whole, so we got 5x squared times the derivative of the top. What's the derivative of the top? 0 minus the top, which I'm going to put in parentheses because it's got a negative, times the derivative of the bottom, 10x, all over the bottom squared. And notice how I write the bottom. Okay, notice that you put the 5 and the x squared in parentheses because that whole piece is squared. The 5 is also. Okay, so if I simplify on the top, what happens to my first term on the top? 0. Okay, so then I have minus negative, so let's call that positive 90x. What's on the bottom? (25x to the 4th). Why is what? Okay. And then I can simplify because we can reduce that by 5. What does that reduce to? 90 would turn into 18. So 18 fifths. And then since I have an x over x to the 4th, turn into x to the 3rd. Okay, so what do you guys think? Was it faster or easier? Maybe easier is a better comparison. To do the quotient rule here, or to use the basic and pull the x up and make it a negative? Because sometimes people get confused with negative exponents. Which one do you think is easier? Using the quotient? Okay. Okay, so do the method that is easier for you. The one that makes more sense to you, use that method. Okay. Huh?
I think it would be easier to do the other way if there wasn't the 5 with
Oh, you have a tendency. You did? Uh-oh. Okay, so if you did it the other way, your rewrite would have to be -9 fifths times x to the -2.
Oh, so this is on the bottom?
Yes. Mm-hmm. So then you would get 18, right, only the x. Okay, and then at that point it becomes equivalent.
So do you multiply the 2 only about the top?
Yep. Mm-hmm. Mm-hmm. All right. So the next part of this is finding derivatives on the calculator. Okay, so everybody grab your TI Inspire. I'm going to do kind of a quick how-to on all of this, at least the best I can. Mine was acting a little finicky before. Hold on, let me try to clear out what was there before so I... So, by the way, if anybody is interested in getting the software that I'm using right now, I have, when we bought the calculators, it came with free software, so if anybody would want that on a computer at home, let me know and I'll give you the codes for it. Okay, and it is a lifetime, so if you are interested in math and planning on going into engineering or math, this might be a software that you'd want to have forever. Okay, so just let me know. Okay, so how to use this thing. Basically, on the top button, okay, the little home, the house, that's the home screen. Okay, so this thing is capable of doing a lot of different things. You can do, there's like a geometry sketch pad thing, there's like, you can do Excel, you can do statistics on it, you can write but in this class, we're going to basically use the calculate and graph that are on the two left. Okay, so to navigate to those, you can either use your little arrow button and get there, or you can just hit the letter A or the letter B, which in my opinion is the fastest way to get there. So we're going to start by going into our calculating, which is our home screen. So hit A. A. There we go. Okay, so I'm going to show you how to do derivatives in the home screen. Okay, so if you hit the menu button, okay, hopefully you've kind of played with this a little bit and seen these things. You see a bunch of different options. The first one at number, well, I guess it's the second one. The first option is converting to a decimal. That's one you're probably going to use a ton, because this will automatically default to exact answer, which is really awesome, but also can be annoying if you're trying to get a decimal answer. So just be aware of where to convert to a decimal. You can do a whole bunch of different algebra. I showed you guys how to do the solving stuff earlier. So click on the calculus one. And the very first option is to take a derivative. Okay, and it pops it down into the derivative notation. Okay, so you have to understand this derivative notation to really do this correctly. If I have d dx, okay, that's going to be the variable usually that you're going to see. Okay, and we're doing question number 4 on your review, guys. Do you see that? So for question number 4, we're going to derive x cubed plus 3 to the x. Okay, so type that in there, which might be easier said than done. So x, and then you have to use the exponent button, which is like right down below the blue button, to the third. You got to arrow out of the exponent. Is it plus 3 to the x or minus? I think it's plus. I don't know.
Where's the caret button?
The caret button is right here. So these two things, by the way, do the exact same thing. The only difference that I've seen, other than the obvious where the little number, the alphabet is this one button right here, which basically is just the quick button to get you between the graphing calculator and the calculating screen, which I really like. I'm not sure how to do it quite very quickly on this one, but it's a small thing. Control to the right. Oh, so if you hit control and to the right or to the left, depending on where that screen is, right? That takes you to the graphing area. All right, anyways, hit enter and we'll pop out the derivative of this function. Okay, we haven't gone over deriving exponents, which we eventually will, but this is the exact derivative of this. Let's say we wanted a decimal version of this, so hit menu and give me the actual decimal value. Whoa, that's not a decimal value.
just give us the one.
Did everybody get that same thing that I just got?
I did.
Did anybody get like we were supposed to get 21? What? Oh, because it's in terms of x. Oh yeah. Silly me. Because this is an answer in terms of x, we can't change the value of that. Okay, so let's do the one in terms of 2. Okay, so now we're going to do the same thing. We're going to go back to the menu. Go down to calculus. Okay, and check out the different options. While we're here, you guys, look at the different things that this can do. It can do a limit. Yeah, it can do limits. It can, it does factoring. Okay, we can find the derivative at a point. Check out number 9. It also finds a tangent line. Okay. Yeah. Probably. So once we choose add a point, everybody plug in a variable of x. I think it automatically defaults to x. And then we're going to do at 2, I think is the one they want us to do. And then choose OK. Okay, and then we're going to type in our function, which was 3 to the x plus, oh, son of a gun. I was even looking at it. I was looking at the wrong one. Actually, I can go over. Yeah, right, it's addition, so it doesn't matter, does it? I'm going to just do mine backwards. There we go. Okay, so it gives it to you as an exact value, and then you convert it to a decimal, because probably that's how you're going to see it in the multiple choice section. So hit math and then number. Yeah. So, yeah, I don't know. And I don't know how to make it default to decimal. I'm sure there's a way you can change the mode and do it that way. But I don't know if it would be, like, you'd want to do that. The last box.
After x equals 2 arrow.
X equals 2. Right. Right, past this? Pass on this side, you just hit enter.
Hit enter. So what's the natural?
What is the natural log? Natural log comes into play because it's the inverse of an exponential function.
Why did I get that?
We will eventually go there. Well, let's go back to you. Oh, your exponent. See on this right here? This is all in the exponent. You need to get down on this.
Wait, what did I do wrong?
You wrote the same thing twice. You have x to the third plus x to the fourth. You have x to the third plus 3 to the x. How do you do it? Distracts. It's like you're in the middle. Oh, you're like doing a limit within a derivative within a limit. You're in a bad spot. Like,
You're doing advanced math.
you're doing, yeah, you're like that. Right.
You're doing math.
That's really yucky.
Did you get 15 the first time?
What? I got 21. I don't know.
It messed up.
Okay, so everybody good with finding the derivative using the calculator? So now you can check all your answers. Now, when I give you these calculators, I assume that when the book says do this without using a calculator, that you do it without using a calculator, and maybe you verify with the calculator to make sure you did it right. How do you do it?
You go control your home button to get the settings.
Control.
Yeah, and you hit the home button to get your settings. Then you go to settings and settings. No. Wait.
Oh, let me. Oh, because yours is in settings. Yeah, it's alright. I'll figure it out later. Okay, so the other thing I want to go over is the graphing part, okay? So everybody following with me? Okay, so we're going to hit, go back to your home screen. We're going to go to graphing now. So I'm going to show you the kind of itty-bitty pieces of graphing. Enter. Okay, so when you initially get there is no like y equals, like you see, there's no y equals button on the 84. So what you have to do is you have to hit tab. So tab is going to pull up your functions. Okay, so right now I have one written in. I'm going to delete it. Actually, I'm not, because that's the function I need to write in. Okay, so hit, in your graphing, just hit tab. And you should see F1 pop up. Okay, so we are going to do question number 5 now off of your thing. We're going to graph the natural log of x squared minus 3. Okay, x squared.
Where did you get the L?
It's second, and then it's like on your button is right above the on button. Was it minus 3 or plus 3? Minus 3.
Where is your natural log?
On yours, it's like, here, look at me. Control, it's right here.
This is x squared minus 3.
Did everybody get that function?
What are we doing here?
The natural log of x squared minus 3. Did you get it? Okay, so the other thing that the calculator can do, and this actually can be done on a TI-84, it can graph the derivative. Okay, so if we have no idea what the actual function is, like, can you guys derive that right now? Anybody know what the derivative of the natural log of x squared minus 3 is?
2x.
No?
Natural log of 2x.
No, not natural log. I'm going to teach you how to find it algebraically. It's actually super duper simple. But pretend you don't know and you have to use the calculator to come up with the graph. Okay, so check this out. There is another way to type derivative in the calculator other than going to the menu thing. Okay, so on the black calculator, well, it's on both, don't worry. It's just a different way. Okay, you have to see this little button that kind of looks like a piecewise function right here. When you push it, there's a whole bunch of different things that pop up. Okay, on the silver, all you have to do to get to it is you just have to hit Control, and then it's this one, that's the multiplication button. It's the same menu.
You can do one of those things called.
Okay, so there is a whole bunch of cool stuff that is within this little area. You can do square roots. Notice square roots are in here. You can do matrices. You can do summations. You can do first derivatives, second derivatives, 10th derivatives, integrals. You can do limits. Anyways, we're going to choose this option right here because we're just on this part. Okay, so arrow over there.
What about
The other, you're in the same spot, so which calculator do you have? This one? So same thing, you're going to hit Control and then times to get to that same button. It's the same button. You just hit right next to the 9 key. Did you find it? And for some reason, this is not working on my software.
We just hit enter.
Yep, hit enter. I'm just trying to hit enter.
Nothing happened.
Nothing happened on yours either?
No. Or mine.
Mine's frozen.
Well, once we click
Hit
that
enter
through,
like 6 times.
Did you get the notation? Oh my gosh, I'm like killing it.
It's not well. I know, we only got like 2 minutes.
Okay, let's try this again.
Thing, like, so,
There we go. I'm moving.
alright, so then you just do.
Come on, work. There we go, I got it. That's what it should look like.
Okay, how did you get it to work?
Oh,
I
yeah,
don't know.
make sure you have the tab.
Oh, I'm so good.
Oh yeah, you gotta type it in. So hit tab and then enter it into the F2.
Oh.
Sorry, minor details.
How do you?
Okay, so then what we're gonna do when you type it in, since we don't know what our function is, we're gonna take the derivative of what we typed into F1. So we're gonna literally type F1 into that spot. Okay, so like with the F button, and then a 1, and it'll like change into the notation. And we have to say of x, so we need to say parenthesis x, and it should pop out, and then hit enter.
Wait, what did you do after the F1 part?
Of x, so parenthesis of x. Yep.
And then hit enter. Wait, where are my prints?
Type that.
Did it work?
Question.
You'll get better at it.
Where
It is totally. Okay, so what I want to talk to you guys about on this particular thing is, I found this really interesting because when you do this exact thing on the TI-84, you get a function where the red part, see the John Travolta that's in the middle? It doesn't graph that piece. Okay, and that should be how it should be. It should not actually graph the John Travolta, and I'm not exactly sure why the Inspire is in fact graphing it. More research, I guess, that I have to do. But if you think about it, okay, if I look at the blue function that's written there, notice that there is basically a gap. The function does not exist between, let's just call that -2 and +2. Okay, so is it possible for the derivative to exist in that area? No, right? If the function doesn't exist, it can't have a derivative within that area. Okay, so just be aware that the calculator can do some really amazing things, but it also can do some things that you can't explain of why it would do something like that. I know why it is doing that because it is actually graphing the actual derivative without using its constraints, but it should use the constraints.
Is there any way to put the constraint?
That's a good question. That's what I need to figure out.
And I found out how to do it.
Oh, okay. So, just so you guys know, your assignment is to do that first page of 3-2, so 1 through 18. Okay, that'll be due on Tuesday. Okay.